Hello, my dear students. Welcome back to my class. In the series of learning programming in C, in the previous video, we have discussed about callback function. So we have seen the application of function pointer. So we have done with the pointers and all its concept. Well, in today's video, we will start with a new concept called as structures. So why we require structure, how to define a structure, how to declare a structure, let us understand in today's video. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Structure. So what actually this structure is? Let us understand the definition first. So structure is a user defined data type. Means the user is going to define a new data type. Hence it is called as user defined data type. Well, in the playlist, please check out data types and its classification. There you can understand what actually this user defined data type is. So we have different data types. We have fundamental data types, we have derived data type, and we have user defined data type. So structure comes under the category of user defined data type. And what actually the structure is going to deal with? It is going to store heterogeneous type of elements. So what is this heterogeneous type of elements? Elements of different type. See, for example, we have seen normal variables. I just say int x. When I say int x, I know that this variable is of integer type, which can store a fundamental data type that can store elements of or a single element of whole number. Integer means whole number. So this variable can store only one value. So as soon as the compiler encounters this variable declaration, it can also initialize the value for this. I say x equal to 10. So what the compiler will do, it is going to allocate a memory for that, and 2 bytes of memory will be allocated if it is 16-bit machine, and the value 10 will be stored. So a single variable can store single value. A single variable can store only single value. If I just say I want to store one more value, can I say 10 comma 20 here? No, that is not possible. So what I have to do? I have to go with one more variable. So I need to create one more variable. I'll say int y equal to 20. So the value 20 is stored here. So when the value 20 is stored, so y is another variable now. So when I say y is another variable, it is storing a value 20. So like this, if I want to store many values, so I need to have many variables. So it's quite difficult to manage many variables, different variables. So what is the solution for that? I go with arrays. So I want to store the roll number of 10 students. So what the array says? You allocate a block of memory, and in that block of memory you can store multiple values, but those multiple values must be of the same type, that is integer. That is what the drawback of array. Array says it is homogeneous collection of elements, means elements should be of the same type. But if I want to store multiple values of multiple types, so for example, if I talk about this pen, I can say the size of the pen, color of the pen, and cost of the pen. Size, if I just say in whole number, it will be integer. Say if I just say the color, it is character array once again. Then if I just say cost, it will be float. So I have integer, I have character, and I have float. Different types of data. So an entity represented with multiple types of values. And these multiple types of values I cannot represent with arrays. Array says it can store only homogeneous elements. It's a collection of homogeneous elements. Elements should be of the same type. Of course, a block of memory will be allocated to store multiple values. But those multiple values must be of the same time with respect, same type, data type with respect to arrays. So I have to store heterogeneous types, means I have to go with this structure. And hence it is saying it is heterogeneous type of elements, means values of different type, multiple values of multiple types. And it says it is user defined data type. Of course, user is creating a new data type. If I just say fundamental data type, it is integer, float, character and double. If it is derived data type, then it is been derived from the existing. Say it is integer array. So I just say array. Array is a derived data type. Arrays, functions, pointers, reference, all these are derived data type. So if I just say array, I cannot simply say array. I need to say integer array, float array. So it is taking the help of the existing. It is been derived from the existing. But when I say I want to create something, a new data type, then I have to go with structure. And hence it is called as user defined data type. User is going to define a new data type. So how to define that data type? Let us see that now. So let us see the structure definition, its syntax and example. So what actually the structure definition is, as the name itself tells you, it is going to define the structure. So structure is a user defined data type, means the user has to create a new data type, so that definition has to be specified clearly. So how do I specify the definition? When I say it is user defined data type and it is going to store multiple values of multiple type, means it is representing an entity. So I have to mention the name of that entity that is going to represent different types of values of multiple types. So the keyword used here to define a structure is struct. It should be in lowercase, followed with the name tag. So you have the name tag and data type member names. So when I say the entity is having many members, defining the entity in the sense just explaining or just deriving its features. As in the sense, I need to tell the features of the student. I can say register number, name, class, section, fees and so on. Marks, total, everything. Same way here also, when I say I am providing the details of the entity, means I need to mention the data type of that, every feature. So I just say register number means it will be integer. So I can have multiple members, then close the bracket and a semicolon at the end to close the structure definition. Let us see an example. Keyword struct, I am defining the entity student. The members I am defining, 3 members I am defining. It is register number of integer type, character array, it is character. Then we have fees, which is of float type, register number integer, name, that is character array, then fees, which is of float type. So 3 members I have defined. Close the bracket and semicolon. So my new user defined data type, my new data type name is student. So this data type specifies that it can store these variety of data. When I say integer, it can store whole numbers. So the compiler know what type of value it can store. But when I say I am defining, the user is defining the data type, so that new data type name I need to mention. So I say the new data type name is student. So what this data type can store? What are all type of values? What are all the types of values it can store? I need to specify it. The new data type name is student. So what the student can store? I need to say. When I say the derived data type array, I say integer array, means it is multiple values of integer type, I say. Float array, multiple values of float type. Character array, multiple values of only character type. So it is only integer type, only character type or only float type. But structure is not like that. It is saying it can store multiple values plus of multiple type. So which are all those multiple types that I need to define here. So I say I want register number of integer type, I want name of character array type, I want fees of float type. So my data type is ready now. So the data type name is student and I can say this student can store 3 multiple values of 3 types, multiple types, integer, character and float. So now the data type is just ready, but memory allocation will not be done for this. So I only define the name tag and members in the structure definition. So what is structure definition means? It is the process of defining the name tag and its members. But there is no memory allocation. There is no memory allocation because say if I just say integer, Do we get the memory? No. I'm just mentioning the data type. When I say a variable by name x, then the memory will be allocated. I say x gets a memory of 2 bytes because it is of integer type. The same way, now I only have this data type. My data type name is student. If I just say student, it is not sufficient. I have to have a variable of that data type. Then the memory will be allocated. So structure definition will provide you the name of the data type followed with the members that specifies the different type of values that what I can store for that data type. But using that data type, when I create variable, then the memory will be allocated for that. For definition, there is no memory allocation. Now let us see the structure declaration. Structure declaration. It says just like variable declaration. But now this is the user defined data type that what the user has created. And for that data type, I am creating variables. So how to create that? I say struct followed with name tag, variable 1, variable 2 and n number of variables and semicolon. An example, the keyword struct followed with the name tag. Let me take the same thing, the same example. Student, the new data type, followed with S1 and S2. So when I say S1 and S2, now the memory is allocated. So now it is just like variable declaration, we have structure declaration. So when we do the variable declaration, obviously memory will be allocated. So my new data type is student and I am creating the variables of that S1 and S2. So now memory is allocated for this. So how the memory is allocated for this? It says for S1 I got the memory, right? So I will be getting the memory for the 3 members, which is register number, name and then fees. So this is register number, this is name which is an array, then which is one more, that is fees. So here when I say S1 means I am dealing with one student, student 1, register number, name and fees. Multiple values and of multiple types. With respect to one student, it's done. If I say again S2, again I am going to get the copy of register number, name and fees. So it is register number, name and then fees array. So it is with respect to second student. Second student, register number, name and fees. This is how the memory will be allocated for the structure variable. Then how to access these members? That we will see in the next video with a complete program. So stay tuned to my channel. We will see the next content of how to access these members with a complete program. See you in the next video. Till then, take care. Bye-bye.